Okay, and then let's take a little bit of a break from trig, it would seem. But hey, maybe it'll come, maybe some trig, and hopefully as we get into the later part of the paper, we can combine the two a little bit. But let's go easy for now, right? Remember our first strategy, let's read through what we're given, let's see how it matches up with the picture and try to make sense of it a little bit, and then we can go through our questions, and only two of them. They're small enough that it's not going to be too much, hopefully, will it? I don't know. So we got these points. There's A, B is sitting over there, C down here, D. We're given very little information. Well, A and C, we're given their full coordinates. B and D, presumably we're going to find T and P at some stage. And what else are we given? It's right angled. Okay, so we're given this right angle. Now, I already had a question in the paper that dealt with right angles. What do you know about two straight lines that are at right angles to each other? Well, I'd say that their gradients, when you multiply them together, give you -1. And if that's the case, then if you've got the one gradient, you can work out the other gradient. So already we can work out the gradient of AC. Look at that. There's a point, there's a point. You know that gradient is just rise over run. So basically what we're doing now, and remember we're doing this exam to practice, not just to practice, oh, here we go, let's solve each question, but to give ourselves confidence of, hey, throw a question at us. We're given a scenario, and you can ask us a few things, and maybe you're going to give us some more information along the way, but maybe not, and we're going to figure out things like, could you work out that angle? Could you work out that angle? Could you figure out the length of these lines? Could you work out the area of this triangle? Really, just let's explore these things and then see what questions come, because this may be 2 questions worth 3 marks each, but this could have been a page of questions worth 20 marks altogether and asking a whole lot of things. But then we've missed out that opportunity to practice. Doesn't seem worth it to me. Okay, so let's see. We said that we could work out this gradient. If we can work out the gradient of AC, we could quite confidently work out the gradient of DC. So matter of interest, what's the gradient of this line here? Well, it's 0. As you're going along, doesn't go up or down, just goes along. So our gradient's 0, just something out of interest. We know we can work out that gradient, that gradient. If we could work out P, could we work out this distance? Yeah, distance formula. We already looked at it. We used it once before. So we're going to work out distance. Well, we don't need distance formula for AD, do we? Can you see how would you work out the length of AD quite easily? Well, -5 up to whatever that point is. That's 5, whatever this point is. I don't know what it's going to work out to be, so whatever it is, you could just add them together. So you don't need distance formula for that one, because it's a horizontal line. Same for vertical lines. Okay, so T, it looks like this thing here is a straight triangle ACD. Okay, triangle ACD means this must be a straight line, because it's not like it's a triangle that's going to go like that. That's not a triangle. Like that triangle, 3 sides. So it gives us that same information twice when it comes to the first question. A, B, and C are collinear, but we know that they're collinear. What does collinear mean? It just means they lie on the same straight line. Here we go. That. What do we know about points that lie on the same straight line? Well, it relates to their gradients, and their gradients must be the same. So the gradient, and you're going to use some combination here. This gradient, MAB, is MBC. Well, and that's also the same as MAC. No matter what gradient you work out, come on, it makes sense. Like there, let's see, I've changed my setup. So there's the gradient, right? It doesn't matter where on your line you use, your gradient's going to be the same. So we said that we could find out the gradient of this line, so that's going to be easy. Might just form an equation along the way somewhere, but basically rise over run, we can get that. determine the value of P, the x-coordinate of point D. Okay, so what's our thinking for this one? It's not like we've got this distance or anything. We do know that we can work out this gradient here as well. So M, smiley face, we know what it is. Could you work out what the equation of that straight line is? Well, yeah, you got gradient and a point. We did that earlier in the test, so you're going to sub in. So if you've got the equation of this straight line, y equals whatever it equals, and you've got the y value, can't you work out the x value quite easily? No, just sub 3 equals. Okay. So, but as I said, you could have been asked a range of questions on this diagram and then said, hence determine the value of AD. I mean, this second question could have said that. Instead of doing that, it could have said, determine the length of AD. And you would have gone, the length of that, what do I need for that? Well, I definitely need point D. So you'd need an extra step to get there. But yeah, just think about that. Okay, cool. Well, that's that one.